Hello, this is Professor Kuehn. In my last lecture, we began looking at Newton's book, Opticks. We looked at the first 5 definitions at the beginning of his Opticks. Let's continue with definition 6. In definition 6, Newton says that the signs of incidence, reflection, and refraction are the signs of the angles of incidence, reflection, and refraction. So you might recall that he's here talking about a situation where you have a surface like this. Perhaps this is a surface separating glass from air, and you have a ray of light incident upon the surface, and then that ray of light either reflects off or continues into the medium like this. And you might recall in our previous definitions, he mentioned what he means by the angle of incidence, which would be this angle right here. I'll put a theta sub I for angle of incidence. This would be the angle of reflection. I'll put theta sub R. And here would be the angle of refraction. I'll put theta sub O capital R for refraction. And here in definition 6, he's merely mentioning that when he talks about the signs of incidence, or the sign of incidence, he means the sign of the angle of incidence. So if he says the sign of incidence, what he means by that is the sign of the angle of incidence. That's what he means. And likewise with sign of reflection and sign of refraction. Let's move on right away to definition 7. He says, the light whose rays are all alike refrangible, I call simple, homogeneal, and similar. And that whose rays are some more refrangible than others, I call compound, heterogeneal, and dissimilar. What does he mean here? He says if you have light that is striking a surface, let me use blue to stay consistent. If you have a surface like this, once again, and you have a ray of light that is striking this surface, in this direction, he says in some cases you can have it comprised of light that bends all by the same amount, or you can have it comprised of light that bends by different amounts. So let's suppose that this is a compound or heterogeneal or dissimilar ray. In that case, then this incoming light is really comprised of several rays of light that each bend by a different amount. And he would say that this would be a compound ray because it really is compounded of light rays of different kinds that bend by different amounts, have different refrangibilities when entering that medium. On the other hand, if, for example, you have a ray of light that is striking a surface, and when it does so, it retains its identity as a single ray, that would be, he says, a homogeneal ray or a simple ray. Okay, that's what he means by this. Okay, let's go on to definition 8. He says that the colors of homogeneal lights I call primary, homogeneal, and simple, and those of heterogeneal lights, heterogeneal, and compound. We're going to find later on that compound rays, the reason why they are separated into different beams that are refracted by different amounts is because different colors of light refract by different amounts. So for example, if the beam coming in was comprised of white light, then when you hit this piece of glass with white light, you're going to have it separate into a rainbow of rays. So the red rays will be bent least, and the blue rays will be bent most. So there will be a rainbow spreading out here. So if I were to represent this in terms of the colors, you might have red rays continuing on at this angle, and blue rays continuing on at this angle, and perhaps the yellow like this, and the green like this, so it's going to separate into different colors. And that's the basis of why one would get a rainbow. He says he's going to talk about this later on in the discourse, but this compound ray is one that's comprised of different rays of different colors that bend by different amounts. Okay, now let's move right along into his axioms. Like I said, this is mirroring the structure of his Principia. In the Principia, one started with definitions and then went on to axioms. Likewise, in his Opticks, he starts with definitions and then he goes on to his axioms. So let's talk about these axioms. This is on the bottom of page 141. So first of all, axiom 1, he says the angles of reflection and refraction lie in one and the same plane with the angle of incidence. What does he mean by this? So let's talk about axiom 1. He's saying suppose we have a surface. I'm going to draw this in 3 dimensions now. Suppose we have a surface like this, a glass block, And suppose that we have a ray of light that is coming in like this and striking the glass block. And suppose that we have some of the light that is going into the glass block and some of the light that is reflecting off of the glass block. What he is saying here is that all three of these rays are going to lie in the exact same plane. So if I were to draw a vertical plane like this, then the incident beam, this is the incident beam, and the reflected beam, and the refracted beam, they all lie within the same plane. That's what he's claiming here. By the way, this is a somewhat controversial claim, not at this point, but when he begins talking about, and when Huygens begins talking about birefringent materials, that is, materials like Iceland spar or calcite, we're going to find that this is not always the case. Okay, so now axiom 2. The angle of reflection is equal to the angle of incidence. What is he saying here? Axiom 2. Well, he says if, for example, I'm going to go back to just a two-dimensional drawing. If you have a ray of light coming in like this, and it bounces off a surface, and you were to draw a perpendicular to the surface, and if you were to measure the angle of incidence, and you were also to measure the angle of reflection, what this is claiming is that the angle of incidence is going to be equal to the angle of reflection. That is his second axiom. Notice this is no longer a definition. It's not simply saying, when I use these terms, this is what I mean by these terms. Rather, it's making a claim about how nature actually behaves. Likewise with axiom 1, it's not simply a definition. It is saying if you have an incident beam, the reflected and refracted beams will lie in the same plane. It's a claim about the way that nature works. Okay, we're going to pause there and pick this up next time with axiom 3.